Hi, this is
Hi.
What's going on? I cannot see. This is really weird. Okay, this is our screencast of Ice and Water.
And why ice floats on water.
Yeah. Okay, wait. Okay, I'm doing this pen and drawing at the same time. It's kind of hard.
Should I do it?
No, let me.
You sure you can handle it?
I can handle it.
Okay.
I got this. Okay.
Just making sure.
First off, let's start with why objects float. There are two main reasons. An object floats because it is less dense than the object it's in. Obviously, it's going to be heavier than the water that I'm going to put it in, so it's going to sink. But if you get a rock that's the same density as water, then it's going to float.
Impossible.
Pretty much. Shape also has an effect on water.
What? You should
Say
it
I have
next time.
a ball of clay. That
Okay,
is a
that's-
gross color.
That's a circle.
That's a ball of clay.
Okay.
Cassie.
Okay.
If it's more compact, which makes it more dense. And if I drop it in the water like the rock, it's going to sink. However, if I mold it and I make it into a canoe,
It displaces more water.
and it gets spread out, and it's not as compact.
So it
So
floats.
it'll float. So that's why shape has an effect on whether stuff sinks or floats. Who's
Michaela. I draw. Michaela
Okay.
talks.
So ice floats because it has a lower density than liquid water. The hydrogen has a positive energy force
Hold on.
and the oxygen has a negative one. So these, when they reach the freezing point, have to balance out, and therefore the positive repels the negative, or attracts to the negative, and the negative to the positive.
And just to throw
So-
something in there, ice has a density
Why are we
of
still using brown?
0.9167, and water has a
Sorry.
density of 1 grams per cent.
And so, because the positive attracts to the negative and the negative to the positive, they make a crystal lattice in the shape of a hexagon. So, therefore, there's more space between atoms, making the ice have a higher volume than water, and making it have a lower density.
It's better than water, which is all over the place like that.
More organized.
Now you good?
In our lab, we took a Diet Mountain Dew and a regular Mountain Dew. One is supposed to float, and one is supposed to sink. When we put them in the water, the Diet floated, and the regular... Floated is not a word.
Okay. The diet floated on the top.
The Diet floated.
And the regular sunk. The diet represents the ice, and the regular represents the water.
Diet contains a sweetener in it that weighs less than what sugar does,
So the mass in the diet is less than the mass in the regular.
which therefore will make it different densities.
So that's why the regular will sink, and the diet will float on top of the water.
Just kind of screw all over the place, don't you?
Hey, that's not nice.
So the diet is like the ice, like she just said, and the water is like the regular. Okay, so now it's time for the summary.
Go ahead. This is yours. Anyways, well, ice floats on water because of its molecular structure.
And its molecular structure changes because of the hydrogen being positive and the oxygen being negative.
Its molecular structure makes it have a bigger volume, which in turn makes its density less. In our lab,
The diet represented the ice, and the regular represented the water, because obviously the diet floated as ice does, and the diet's density is different than water, just like ice's density is different than water. And that's pretty
that's
much it.
pretty much it.
Bye.
Right at the end.
Wait, I gotta do it.
Not gonna fit everything.
Probably not. I'll go like this. Let go. Bye-bye.
Bye. Wait.
Maybe.